Hello girls and boys, today we will be studying and reviewing our lesson, which is Sun and Earth. The Sun and Earth lesson is divided into two parts, the day and night and the seasons. Now we will start with the day and night. And before we solve these exercises, I would like you please to watch videos 3.1 and 3.2 and check activity number 3 found on your dashboard. Plus, please read Unit D book from page 318 to page 320. Now, let's see. Let's look at each picture. Over here, we see that the sun is moving in the sky. Actually, the sun is not moving in the sky. The earth is the one who's moving. So the sun is fixed in its place and the earth is the one who is turning around the sun. Not only it's moving around the sun, but also it's moving around itself, and we will see all of these in this presentation. I would like you now to see that when the sun is low in the sky and it's rising from the east, this is morning. And we call it the sunrise. Let's look at the shadow of this tree. When the sun is low in the sky, the shadows will be long, as you can see over here. Now, at the middle of the day, when it's noon, and we can say that it is midday, the sun will be high in the sky, and this will let the shadow to be short. Now when the sun is setting, or it is afternoon and it's before the evening time, again the shadows will be long. So the first picture, when the sun is low and the shadows are long and it's in the east, it will be the sunrise and it's in the morning. Now the second picture, when the sun is high in the sky and the shadows are short, it will be the midday. And the last one, when the sun is setting from the west and the shadows are they are long, this we call it the sunset. All of these are happening simply because the earth is rotating around itself and not the sun. The sun seems to move across the sky, but actually it's not moving. Now, this is the earth and this is the sun. The sun is fixed in its place, whereas the earth is the one who's moving. Let's look at the earth. The earth, as if it's divided into two parts. One that is lighted up, and the other part it's so dark. Simply because this part is facing the sun, and the sun rays are reaching it, and it is letting it to light up. So people living in this part, they are not sleeping, they are going to their work and they are studying. So over here we have daytime. Whereas the other side of the earth, by which it is facing away from the sun, this side will be dark and the people over there will be sleeping simply because it will be nighttime. So as you can see, we have daytime and nighttime. But the daytime, or with this part of earth, will not stay having daytime the whole life. It will switch and it will have night, and this part will have day again. This is because the earth is rotating around itself, and specifically it's rotating around this line. Who can tell me what do we call this line? We call it the axis. And in real life, the axis is not found. That's why we say that the axis is an imaginary line. The scientists just drew it on books to know exactly how does the earth move. And we need to know that it passes from the North Pole, which is the upper pole, to the South Pole, which is the lower pole. So let's choose the correct answer from these questions. I will pick up my pen and you will help me to solve them. While the earth is rotating, it is what at the side that is facing the sun? Let's go back to the picture. This part is facing the sun. It's looking at the sun. What will this part have? Daytime, nighttime, or moon? It will have daytime because it is lighted up. Now the second one. What is an imaginary line that passes from the North Pole to the South Pole of Earth? It is, what do we call it? Do we call it center, axis, or rotates? We call it the axis. Can you point at the axis? It's over here. This is the imaginary line I'm talking about. Earth needs what to complete one rotation around itself? So to have a day, for example, today is Monday. For Monday to finish, we need to have one day to have Tuesday again. So this is for the Earth to rotate around itself. It needs one full day. And how many hours do we have in one day? We have 24 hours. So again, for the Earth to finish one rotation and to finish one day, for example, to finish Monday and to have a Tuesday, we need 24 hours. So to complete one rotation around itself or around its axis, what do we need? Does it need 2 days, 1 week, or 1 day, which is 24 hours? It is 1 day or 24 hours. Now it's time for the seasons. So let's sum up before we go to the seasons. We have day and night simply because of Earth rotation, and we need 24 hours or 1 day to complete one full turn around its axis, which is the imaginary line. Now, this picture is showing the sun, and it's showing a circle by which the Earth is following. This is, we call it the orbit. So the Earth is orbiting around the sun. But in grade 3, we don't say that the Earth is orbiting. We say that the Earth is revolving around the sun. And remember, we did a nice demonstration in class. So here, the Earth is revolving around the sun. Now, for the Earth to finish all of this big circle, it doesn't need 1 day. Who can tell me? It needs 1 year. Excellent. So let's fill in the blanks. Now, the first one. Earth revolves in a regular path around the sun called the, so what do we call this pathway by which the Earth follows? Do we call it orbit? Do we call it rotate, or we call it axis? I call it axis. No, it's not. The axis is the imaginary line found at the center of Earth. Do we call it rotate or orbit? We call it orbit. But please keep in mind that also orbit is an imaginary line. It's not found. Also scientists drew it to know exactly where does the Earth move. Now, Earth needs what? To revolve around the sun. So, to finish this big orbit, does it need 24 hours, 1 year or 365 days, or 2 months? It needs 1 year. It doesn't need 24 hours. This is for rotation, not for revolution. Talking about revolution, let's see. What is the movement of Earth around the sun? What do we call the way the Earth moves around the sun? Do we call it rotation, revolution, or jumping? Of course not jumping. Of course not rotation, because it's not around itself. We call it revolution because it is around the sun. Talking about revolution, let's see now our Earth. Our Earth is revolving around the sun, as you can see in this picture, and we will study 4 different positions of Earth. We will study position number 1, 2, 3, and 4, as you can see in this picture. Now, let's see in position number 1. Position number 1 is showing the northern hemisphere and the southern hemisphere. Northern means the northern hemisphere means the upper half. Hemisphere means half a sphere, half a ball, and the lower hemisphere. Now, if we look at the upper hemisphere, We looked at the North Pole and we can see that it is tilted toward the sun. The word tilted itself means that the axis is not straight up. It's a little bit tilted or slanted, we say. So here when the North Pole is tilted toward the sun, this means that all of the sun's heat can reach this place, and this makes the weather very hot. And during which season do we have hot weather? It is summer season. So over here in position number 1, the North Pole or the upper half is having summer. Let's go to the opposite side of the picture, which is position number 3. And again we will look at the upper hemisphere. The upper hemisphere over here is not tilted toward the sun. It's tilted away from the sun. And this makes the weather very cold. And we all know that winter is the season by which we will have cold weather. So over here we will be having winter. So position number 1, the upper half will have summer, and position number 3, the upper half will have winter. So let's see now position 2 and 4. Let's fill them. After summer, what do we have? We have fall. After fall, we have winter. After winter, we have spring. So this is spring and this is fall. That's why they are in the middle, because their weather, it is not extremely hot and it's not extremely cold. It's moderate. We say that as if it's in the middle. So the earth is revolving here following its orbit. And what does it cause? So the earth revolution causes the seasons to happen. So the earth rotation causes day and night, whereas the earth revolution causes the seasons. That's why we have 4 seasons during 1 year. So to finish the orbit, we need 1 year or 365 days. So let's answer these questions. Look at the North Pole in picture number 1. So this is picture 1. And let's look at the upper half. What will be the season in that hemisphere? Who can say? It is summer. Good job. Now the second one. In picture number 3. Let's go to picture number 3. Listen carefully. When the upper hemisphere is tilted away from the sun, what is the case of the lower hemisphere? So if the upper half is tilted away, what about the lower half? It will be tilted toward. So it will be tilted toward. So put in mind they are the opposite. When the upper hemisphere is having winter, the lower hemisphere will have summer. So pay attention. But in this picture we are focusing on the southern hemisphere or the northern hemisphere or the upper hemisphere. Now the last question. In picture number 3. Which season it is in the North Pole? It is the winter, as we explained. So for more details, please, I need you to read your book. This is just reviewing the main ideas of the lesson. Thank you so much. Study well and stay safe.